So this case here, same thing. You just take note that this expression here, you can see this is differentiate once, right? From here to here is differentiate once. Then from here to here is you need to differentiate twice. In other words, you differentiate here to here once, you get the second derivative. Okay. We start off by just differentiating it. So y equals to sine inverse x square. So dy dx first. Dy dx is just differentiation. So you should know how. Outer layer, inner layer. Then this outer layer will be 2 sine inverse x 1. Inside will be 1 minus x square negative. I think MF26. Is it? You differentiate this, you get this. Then what's the next thing to do? This is differentiating once, huh? How do you get this? You realize that there's this thing here. Squared, right? So you just square both sides, huh? Square both sides, should be able to get the answer there. So square this side, square this side. What we get is so from here what we need to do is square both sides. Square both sides. Then what we get is okay. Square each term. Multiply this above. Cross multiply, and we know that this is our y. Okay, there's our y. So then once we're done, we get the next thing we want to differentiate once more. So differentiate. Then you do the same thing. Okay, this is product rule. Okay, then this one be slightly careful lah. There's a d square y dx square. Later I'll explain how we get there. So dy dx. Dy dx. Okay. So this case here, this is our u. dv dx. dv dx here, you have an outer layer, inner layer. So the outer layer will give you this one here. Inner layer will give you this one here. Then this will be your u square dx. May I rewrite this first? I don't skip step. Um, There you go. By further differentiation, you need to differentiate all the way above degree of 4, right? Meaning you need to find all up the way to d4y dx4. Okay. So meaning to say you need to differentiate this 2 more times. Okay. So what you do is differentiate once more. If not enough paper, you please write in the full scap around. Yeah, d dx. So in this case here, what we get is keep the one on the left, differentiate the one on the right, keep the one on the right, differentiate the one on the left. Same thing. So I'll write this down. This is Q and V. Then this one will be there you go. Yeah. You need to differentiate once more, so differentiate again with respect to x again. So this will be the last round. Then later on you can just go and do some scavenger hunt and just find all the parts you need. This case here, what we do is we get. You don't need to simplify after this. I'll label it down for you. Rule. The next part is Maclaurin series. This is not fun, this question here. So what we want is you go and find all the missing parts that you need from here. Okay, so this one here. What we need is when x is 0, y is how much? 0, right? Sine inverse 0 is 0, so 0 square 0. Then you want to find f prime 0, okay, which is this one. When x 0, y is 0, dy dx is how much? 0 also. So everything you want to find is all here. Just eyeball. You substitute x0 dy dx is y is 0 ma. So this whole expression will be reduced to 1 minus 0 dy dx square equals to 4 times 0. So essentially dy dx is just 0. Okay. Then similarly for the second one, you can use this one here. dy dx is 0. X is 0. X is 0. So this one, you can see d square y dx square is equals to 2. Okay, so here, so of course, you go and find the rest. Okay. Maclaurin series is always x is 0. X is always. So you look at this, yeah. So once done, f prime prime 0, f prime prime. This case here, same thing. This guy is 0. Eyeball only lah. This guy is 0, so the entire thing is 0. This entire thing is 0. This guy is 0. X is 0 ma. This is also 0. So what is left is dy dx is dy dx is how much? 0. So wow, everything is 0. So essentially d cube y dx cube is just a one big fat 0 there. Okay, so this is also here you go. Then you go to this one here. This guy is 0. Actually, just find everything 0 lah. Everything 0 is fun because this is 0, so you render the whole thing 0. This is 0, whole thing 0. D square y dx square is how much? 2. dy dx is so 0. So the whole expression here can be reduced to d4y dx4 plus 0 minus 3, 0 plus 2. Equals to 6. So this case here, f prime 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 0 is equals to 6. So make sure you get all the expression there. So the Maclaurin series, bring out Maclaurin series. Remember last week we talked about Maclaurin series is finding the polynomial. So fx is sine inverse x square equals to f0, which is 0. Here they go. Then you get 6 divided by 4. Painful. Here's 1. So this is dy dx is 1. Then let me just adjust it. This is 1. Because differentiate x is 1 ma. I go and put the stupid thing there. So this is 1. This would be, oh, it won't affect though. So just adjust accordingly. This is 1. This is 8. Because it's an estimation, right? The series is to find pi square. Explain why the 8 over sketch using x equals a half gives a better approximation. So obviously this is closer to 0, so this would be a better approximation, but they want you to explain. So let's try to understand this. So draw the graph first lah. You have got the actual curve, which is this one, sine inverse x square, and then this is roughly equals to the series expansion of 1/3, is it? Oh. Okay, so this is it. We first off, you want to find pi square, right? What is pi square? Pi square will mean that, so pi square equals to sine inverse x square will mean what? Will mean that sine inverse x equals to pi lah. So meaning x is sine pi will be what? X will be 1. Okay. Is it 1? No, it will be 0. Sine inverse pi. So essentially, you want to sine inverse. Later I'll explain to you why we use. Okay, we understand this first. We want to find pi square, right? They say that using x equals to what? Because this may not be the case. X equals to 1.5. Okay, I'll explain the bit. So x equals to half. You have sine inverse half square. What would this give you? Sine inverse half. Sine inverse half is pi over 3. Pi over 6, sorry. 30 degrees. Agree? This is pi over 6. So essentially, right, what I'm saying is this case here, you will get half square plus 1/3 half the power 4. Then this is roughly equals to, so this will be pi over 6 square. In calculator, I'm not sure what you get. So this is how you find the approximation. So when x equals to half, you can find pi square here. I just want to explain the background, backdrop of it. So if you let x equals to 1, okay, sine inverse 1 square, 1 square plus 1/3, 1 to the power 4, roughly equals to, sine inverse 1 will be 90 degrees, which is pi over 2. Okay, so you see, essentially, what we get here is two approximation. If you use x equals to 1, pi square is this exact value here, 9.8969. So 1 is, I think it will be totally off. The 16 over 3 is obviously quite off. The 1 is 5.33 is so off, right? Then the other one is 39 over 4. That will be closer to the actual value. Okay, so this is much closer to the actual value. Do you see that? So essentially, they're asking why this would be a better approximation. So this is very far off. Okay, so the percentage error, if you want to count the percentage error, is you take pi square minus 16 over 3 over pi square times 100%. Okay, the percentage error here will be quite jarring lah. It might be better than not estimating it, because it's not actual an estimation there. Minus 16 over 3. I just multiply 100. 45.9%, bro. 45.9%. The error, the percentage error is 45. Then might as well just don't estimate. This percentage error here, only 0.21%. Okay. So they ask you to use the actual graph. Okay, so now I'm writing this out just to illustrate what is going on behind. You use different x value, you can yield the same result, but different estimate. Okay, so what we do is we're just gonna sketch this graph here, the sine inverse x graph, and then the estimated graph, the estimation graph that we got just now. So see, what we do is we put sine inverse x square. Yeah. Sine inverse x square. Then you clear it. Here you put x square plus x to the power 4 divided by 3. Okay. Then you graph it. Okay. Now this is, oh, I use a dotted line. So let me just clear this. This is the dotted line. So I'm gonna zoom box because there are a lot of wasted white space there. Yeah. There you go. So it's very clear that this is the actual graph. This is y equals to sine inverse x square. This is the approximated curve y equals to x square plus 1/3 x power 4. Okay. So what you need to understand is when x is half, and when x is 2, x is 1, you can see that the approximation deviates. Okay, so so you just write down. So this is the rationale why. They ask for y, right? You just write this down. Then they ask for give your answer in fraction form. Then this is the answer. We are using this one here. I wrote this before. Yeah, this is the answer. So the hence pi square equals to roughly equals to approximating 19/4.